Today I'm gonna be explaining two questions, IB past paper questions, that or paper 2. So let's get right into it. So first question states, state the equation for the reaction between sodium and water. So first off, what is the equation? What does the equation mean? Equation means it's a chemical equation. It's symbolic, and it represents a chemical reaction in the form of symbols and formulae. So we need also to balance the equations. To balance an equation, we created one. The one we created states 2NaS, which means S means in its solid state, plus 2H2O L, which means it's in its liquid state. No, yes, it means in its liquid state, which gives us the output of 2H2NaOH between brackets AQ. AQ means aqueous, which means it is dissolved in water, which means 2NaOH, it is dissolved in water, plus H2 in its gaseous state, which the symbol of it is G. So let's reread the formula. So the formula, we had 2Na in their solid state plus 2H2O in their liquid state. When we added both of these in a chemical equation, when we added these, they both formed a chemical reaction, which made an equation of 2NaOH between brackets AQ, which means dissolved in water, or aqueous, which means aqueous. I'm not sure how to pronounce that, which means it's dissolved in water, plus H2G, which means it's in its gaseous state. Okay. The second question is, state and explain one difference between the reactions of sodium and potassium with water. So, both of the reactions are the same, but there's only one difference between sodium and potassium. One of the difference is that K, which is potassium, and Na, which is sodium, down on the periodic table, they have very high reactivity, but potassium is more reactive. So potassium is more reactive. Why is it more reactive? It's because it's farther down the group. So here is the answer. Potassium is more reactive. So potassium is more reactive, and when you add K or Na in water, you always have to do it in a very controlled environment. You have to have special people around you, or not like experts in what they're doing, because when you add the K or Na in water, you always have, when adding these two elements, they are very explosive, and you need to be very careful because they develop hydrogen instantly, because it may ignite a fire if you when you add these two together. So in conclusion, the difference between the reactions of sodium with water is potassium is more reactive than sodium, due to it being further down the group, down in group 1, and potassium has more number of shells compared to sodium, and it becomes easy to remove one electron from its outermost orbital. So it is one of the most reactive metals in all of the metals, and it's the most reactive. So it's the most reactive metal. So what we conclude from this question is that potassium sodium and potassium are both very reactive, but potassium is far more reactive because it goes down further in group 1 because it has more number of shells compared to sodium, and it becomes easy to remove one electron from its outermost orbital. Between all metals, potassium is also the most reactive metal. So not between sodium and potassium, but also between all the most reactive metal. And this is the answer for the second question. Let's go to question number 3. So it asks define the first term of ionization energy. So what is the first term of ionization energy? So it is the energy required to remove one electron in a chemical bond. So what is it? Let's explain it further. So it is the energy required to remove one electron or remove an electron from a neutral atom in the gas phase or chemical bond. So the first ionization energy means it is the energy required to remove an electron in a chemical bond. It needs to be in a gaseous state and in a chemical bond. So atoms also with fewer energy levels attract more electrons, which means better less shielding, so electrons negativity decrease down a group of elements. That's why we stated potassium when it's further down in group 1, it can attract electrons easier. That's what it means. First ionization energy level. The second question is explain why the second ionization energy is greater than the first ionization energy. So one thing we can conclude just from the answer is this is the first and the second, which shows that the second ionization is always larger than the first ionization level. So as we can say from here, what I wrote is that the second ionization level is always larger. So it's always larger than the first ionization level. Why is that? Because in the second ionization energy, it requires even more energy to remove an electron from cation that's in a neutral atom in a gaseous state. So we can conclude that always there is the first ionization level, which, as we talked, is the energy required to move one electron from a neutral atom in the gaseous state in a chemical bond. It's very important that's in a chemical bond, which is also a chemical equation. And that's it. I hope you liked my video. I hope you understood from it. Thank you. Bye.